Okay, so you look at the first problem and you say, hey, wait a minute, they're not the same radicand. They're both square roots, but one's an 18 and one's a 2. But before you say, oh, I can't do anything with this problem, remember what we were learning in the previous sections in Chapter 8, what we were learning about what is a radical expression and then how to simplify them. So what we have to do is we have to try to simplify the radicals first. So the 18 breaks into 2 times 9. But I can take the square root of 9, which makes it 3 times the square root of 2, plus this square root of 2, that's prime, it's not going to break down, so 6 square root 2. Okay, now we look at the problem and we say, oh, we've got like radicals, yay. So 3 square root 2 plus 6 square root 2, that's going to be 9 square root 2. And we're done. So we have to simplify first, then combine. All right, so our next one, they're cubed roots. I've got a 16 here. So let's see, what's a cubed root that goes into 16? 8. 8 times 2, right? Now, this problem's going to need a little more explaining. So the 6 is there. That's that 6. This 8, that I'm going to take the cubed root of. And the cubed root of 8 is 2. All right? And now what's left is the cubed root of this 2. I'll put it in a different color. I'm hoping the colors help it make more sense. Okay, so the 6, that was already out there. We took the cubed root of 8, I did that in orange, and that became that 2 on the outside. Then this 2, the green 2 here, that was left over, and so it's on the inside. Okay? Now to finish this simplification, 6 times 2 is 12, so 12 times the cubed root of 2. Okay, now we're going to do the same thing with the other part, the other radical. All right, so I have 250. That's 125 times 2. All right, a bunch of 2's here. Minus 2. That's this part right there. The cubed root of 125 is 5. So it comes out, and it's going to get multiplied times that 2 that's already out there. And then the part that has to stay in, that's going to be that 2 there, so it's going to be the cubed root of 2. Okay? So now I'm going to have, when I do that multiplication of 2 times 5, minus 10 times the cubed root of 2. So for your first couple problems, I suggest writing it out like that. Otherwise, it gets really easy to get confused, and you don't want to do that. All right, now we simplified. Are they like radicals? Yes, they're both cubed root 2. I have 12 of them. Take away 10 of them. That gives me 2 cubed root 2. All right, don't forget to put the index. Okay, just that reminder. This one looks a little different. It's got some fractions in it, but fractions don't scare us, so it's going to be okay. I'm doing the cubed root of 81. Well, 81 is 27 times 3. And I can take the cubed root of 27. So I'm going to have the 2/3 out here. And then I'm going to take the cubed root of that 27, which is going to get me a 3. Then I'm going to have left, I'm going to have left this 3 under the radical symbol, so cubed root of 3. A bunch of 3's, and they each are representing something different, but hopefully you can see that. All right, now when I do that multiplication, I'm actually going to cancel that 3 and that 3. So that's going to give me 2 times the cubed root of 3. Okay, so that radical has been simplified. Now we go to the next part. I've got 24. Well, 24 is 8 times 3. So I can take the cubed root of 8. I have minus 1/2. Now that's that part that was already out. Then I'm going to take the cubed root of 8, which is 2. So that's coming out. That part's like right there now, because I had to take the cubed root of 8. All right, and then what do I have left? The cubed root of 3. All right. So now these 2's are also going to cancel there. So that, nice, now I don't have those fractions. Now you might be saying, well, what if they didn't cancel? I'll talk about that in a second. Okay, so you have 2 cubed root 3 minus 1 cubed root 3. That's going to be just 1 cubed root 3. You can write the 1 or you can not. Generally, we wouldn't write it, but just, I know sometimes people like to put a 1 there. But, you know, the more symbols, sometimes the more confusing it is. Okay, now, if they hadn't, if we hadn't been able to get rid of the fractions, we would just have to add, you know, fractions, but that's okay.